Okay, folks, sorry for the interruption. This is part two, and we left off part one with the limits of A being 0 and B having a limit of 2/3 and C having a limit of infinity because there's more X on top than there is on the bottom, like you see here in part A. All right. Now, example 4, I went ahead and filled in all the information. You can go ahead and you can type this in, this equation and your, excuse me, this function on your, actually, you can't type the function. What I will do is I will give you the function here, and I'll give you the function later on, and you can have it look at. But these are the numbers. Now, well, here's what happens. As the limit goes to infinity, and actually, let me write it down. I'm just going to write it down for you. This is what it should be. It should have been included, and I apologize that it wasn't. So here it is. It is f of x. Okay, so I had to pause it for a moment to take care of something at my door, but the function is 1 over 1 plus e to the negative x. So that's the function. And what happens is as you go to positive infinity, everything starts to approach 1. But as you go to negative infinity, everything starts to approach 0. And you can check this out using your graphing calculator and that. All right. Now, once again, you can also do this with your graphing calculator as well. You can plug in sine of x and see what happens as x goes to infinity. But what you see is this. And you know the sine curve, because you've been dealing with this, you've been dealing with the sine curve for a long time now, and it's just going to be doing that. It's going to keep going up and down and up and down. It's going to oscillate. So therefore, does not exist. Does not exist. All right. On the other hand, with the sine of x over x as x approaches negative infinity, this is going to be a little bit different. It's actually, you got to look up the squeeze theorem. And the squeeze theorem, I'll look that up and I'll post it on Canvas. If not, you can look it up on YouTube as well. Just type in squeeze theorem, and there's a video on it. It's on there. You can check it out on your own. And I will try to post this on Classroom, or it's not Classroom. I mean Canvas. I'm still old school. So, but anyway, here's what's going to happen with it. It's going to kind of do something like this. It's going to do this. It's going to do this, and it's eventually going to come together such that the negative 1 over x is going to be less than sine of x over x, which in turn is less than 1 over x. And that, of course, is the limit as x approaches infinity equals 0 here. And on the left, the limit equals 0 as x approaches infinity there. So that's that. That's the squeeze theorem. You can look that up. You can watch the video on your own and check it out at your leisure. And that is section 1.6. That's the last section of the chapter. We'll be getting the review and the test ready for you. Email me if you have any questions, and signing off for the moment.